All right, my name's Cameron DaCamara. First question is, who went to Gabby's talk on Tuesday about persistent in-memory representations of C++? Gabby did not go to his own talk. Okay, cool. So who here thought that after they saw this IFC thing, like, what the heck am I supposed to do with this? Like, how is this possibly useful to me? Okay, cool. I'm gonna hopefully convince you guys that raise your hand that it is useful. Let's first start by looking at a small translation unit here. I have a module which exports some function f in this namespace, and I have an f and a g. I have a class template which has an inner template or inner class with some member function f, some t that's a member. And then we have some stuff that's not exported. So remember that kind of these impl functions are not exported. Beforehand, I went ahead and compiled this thing to an IFC. This is our module format that Gabby talked about. And here's something that's kind of interesting. This is a web page. Why am I opening this? Well, if I take this IFC and I drag it onto the web page, it'll ask me that. So what just happened? This thing just serialized in the IFC, which is fundamentally used for compilation into a web page using JavaScript. And it used the IFC specification that was described by Gabby and the project that's on the Microsoft IFC GitHub. This is the complete translation unit that you just saw. And this is the complete semantics information that a compiler would need in order to materialize any of the declarations that were in that translation unit. So you can kind of like navigate around this thing. You can see here's our S that we had here. Here's that member function. Here's our namespace N with our function F, right? You can kind of navigate around this thing. This was that class template I was showing you with this, this nested class here, U. But that's not all we can do. We can also do things like selections. Like, let's say I want to know all the functions named f. Okay? I want to know only the functions named f that are actually functions, because there's a member function down here named f. So I go function. Okay, let's filter it even further. I only care about all the functions f that are actually exported. So I'm going to filter all the non-exported versions of f, or all the exported versions of f. Okay. Yeah, I only filtered the exported ones because both of them are exported. But if I went to f-impl, both of those functions are not exported. So if I were to hide them, you wouldn't see them. So if I see here, here's all the functions in the translation unit that are actually exported. So it's using the IFC information to drive this graph data and say, hey, you know, I want to do a selection over this graph and only show me the things of this type that are actually exported. So we can see the entire part of the interface now that is actually exported. Or inversely, if we only cared about implementation details, we can filter it down that way as well. The other things that you can explore is, like, let's say I was interested in G, and let's say I wanted to find out what the return type of this thing is. I can go to the type here. So this is kind of like dense information now that we're getting into that the compiler normally needs. I see that it's a function type. I see target here is really fundamentally the return type of the function. It's type index, and it's void. So you can kind of think about this in terms of, hey, you know, I could sort of inspect this IFC outside of the context of the compiler and maybe generate something interesting from it. And as I was writing this thing, this little navigator program, this IFC viewer, I was thinking, hey, this could be a really cool opportunity for something like documentation. That's all I got for you. Hope you liked it.